So how do we tell what that balance is? It could be 50-50, but usually it's not. How do we figure that out? Well, we use what's called an equilibrium constant to quantify the relative amounts of reactants and products in an equilibrium. So if we look at a generic chemical equation, here we have A plus B reacting to form C plus D. This is a reversible reaction. The arrows are pointing in both directions. So C and D can also react to form A and B. The coefficients here, lowercase a, lowercase b, C, and D, are just standing in for the normal integers. They could be 1, 2, 5, 17, whatever. We define the equilibrium constant, K sub EQ, as the ratio at equilibrium of the concentrations of the products raised to their stoichiometric coefficients divided by the concentration of the reactants raised to their stoichiometric coefficients. That's a lot of words. Sometimes it's a lot easier to say it with a mathematical formula or equation. So the equilibrium constant is equal to the concentrations of the products, so C and D, multiplied. And the brackets tell us this is concentration in moles per liter. And each of these is raised to an exponent. Okay? The exponent is the coefficient in the balanced chemical equation. So products times each other raised to the power of their coefficients divided by the reactants. So this sort of follows that pattern of final minus initial. Here it's final divided by initial, because I always had a hard time remembering which one goes on top. It's the products. Products on top, reactants on the bottom. So we can write an equilibrium expression for a chemical reaction. So for this chemical reaction, the equilibrium constant is equal to the product concentrations, NO2 in brackets and O2 in brackets, raised to powers that are equal to their coefficients. So this is to the fourth power. This is to the first power. We didn't write the 1 there. It was implied. We don't need to write the 1 either. It's implied. So products divided by, here we only have one reactant, raised to its power squared. So the coefficients become the exponents. Any questions? Let's write an equilibrium expression for this chemical equation. So K EQ equals, we want the products, here there's only one, so the product, and what's the coefficient? 2. So this is squared. Divided by the reactants, we've got H2 and we've got F2. And what are their coefficients? 1. So we don't have to put a 1 there. So the equilibrium constant for this chemical reaction is the hydrogen fluoride concentration squared divided by the product of the hydrogen and the fluorine concentrations. Any questions? That's how you leave it. There's no simplifying or anything, you just leave it like that. It's way simpler than the words, right? So what that KEQ is going to have a number associated with it, and the way you find the number, let's just go back to this. The way you would find the number for this reaction is you would have this at equilibrium, hydrogen gas and fluorine gas and hydrogen fluoride gas, and you would measure the concentrations of each substance and put them in here to calculate the equilibrium constant. The equilibrium constant gives us information about whether the product side is favored or the reactant side is favored, or whether maybe it's more of a half and half situation. If KEQ is a big number, is this a big number? 10 to the 19th power. That's a really, really huge number. That tells us that it's mostly products and very few reactants. because the equilibrium constant expression for that is HBr squared divided by hydrogen times bromine. Because this is a very large number, that tells us that the numerator of this expression must be really big and the denominator must be really small. So large KEQ favors the forward reaction. If KEQ is small, the reverse reaction is favored. There's going to be more reactants than products at equilibrium. Because here, this is a crazy small number, 10 to the minus 31. This tells us that at equilibrium, there's very little nitrogen monoxide present. It's mostly nitrogen and oxygen. Any questions? So here's the hydrogen and bromine to make hydrogen bromide. That was a large number. So that tells us there's lots of HBr and very little of the reactants left. It goes mostly in the forward direction. For this reaction, KEQ is a very small number, something times 10 to the minus 19. No, minus 31, right? So that says there's very little of the NO, and it's mostly nitrogen and oxygen. We look at this, and yeah, we've got 2 of those, and all of the rest of this is just the reactants, okay? So if KEQ is very small, much less than 1, that tells us that the reverse reaction is favored. It doesn't progress very much at all. If KEQ is very large, it says the forward reaction is favored. It goes forward almost exclusively. If KEQ is approximately 1, then you have more of a 50-50. It's in the middle. Any questions?